Imagine this. 6 a.m., Saturday morning, your bags are packed and you're ready to go on a road trip that you've been waiting for. You hit the road, it's been a few hours already, you're listening to music, everything is going well, and then it happens. That noise. You know the one. The one that along with that light on the dashboard tells you that you're not gonna make it, at least not how you intended to. It's a pretty bad feeling to get. My first car was a 1990 Beetle. When I got it, it was already well over 2 decades old, well over 100,000 kilometers in the odometer. And even though I loved it, it really did give me a lot of trouble because of how old it was. Reliability was just down. One of the things that will happen, for example, is I'll be accelerating and the accelerator will get detached from the carburetor in the back. So you have to fix it, put in a little stone just to pull the carburetor down. Or the battery will die and you have to start it on second gear. And one of my favorites was brakes not working, this old school drum brakes, because of the rain. They will get wet and they wouldn't brake well. In other words, I had range anxiety way before it was cool. Fast forward a couple of decades later, and reliability has increased. So this feeling of I'm not gonna make it, this range anxiety, it felt like a thing of the past. That is until, of course, electric vehicles started to emerge. And they brought that feeling back. Am I gonna make it? Am I gonna hit the charging station? Is this charge enough to get me to my destination? And EV manufacturers know this, and they put a lot of focus on improving the range and performance of the car. Very recently, we saw an announcement of an EV with 620 miles of range, over 1,000 kilometers of range. That's pretty impressive. And the way they did it, it was not only packing more energy. One of the main things of the car was that they had a very low friction coefficient with the air. So the design was made for that. And there are a lot of puzzle pieces that come together to hit this maximum or optimal point of performance and range. And it's really all about the conversion of energy. How are you gonna take what is stored in the battery all the way down to the road through the wheels so you can move the car and just trust that you're gonna make it. And for all of this, design is very important. Not only the design of the car, but the design of the whole drivetrain, etc. But it's test what gets us there for real. That's how we see what's feasible and what's not. So how do we test electric cars? Just a few examples. You can have a digital twin of the car, which is really the car in the computer, and just submit it to some simulation to see how it's going to oppose the air and what you can do in the design so that you can reduce that friction and improve the performance. Or you put these batteries in these environmental chambers and then you abuse them, taking them through temperature cycles, charge and discharge cycles as well to see how they're going to behave in the real life. And you have to run this test for a long period of time with many multiple variables. Or for the whole drivetrain, you can put in a dynamometer, which is really trying to get it into running condition and then tune the algorithms to make sure that that conversion of energy is working as best as it can. And then you do it over and over and over again. There's a lot of repetition, there's a lot of changes, and this is really intense and overwhelming, even nitpicky to some degree. But that's for good reason. And what makes it harder is that there is no playbook and there are no shortcuts. We have to test it all, and engineers have to figure it out. Now, the speed at which we can figure this out matters a lot. We need to increase performance in multiple dimensions. Back to my old Beetle. To save some money, sometimes I would do the brake adjustment myself. So I would just park the car, jack it up, and then there's a little gear that you need to adjust in the inside of the wheel so that the pads get closer or further away from the drum. And that's how you adjust the brakes. So I'll do it with all 4 wheels. It'll take me 3 to 4 hours, but that'll save some money. Now, sometimes I didn't have the time, but I was able to come up with the money. So I would take it to the shop. And then at the shop, they will do the same process, and it'll take them probably 20 minutes. So there's 2 things that I noticed from that. The first one, they obviously had more experience than I did, right? They did this for a living, so they knew exactly what they were doing. But then the second thing is that they had the right tool for the job. While I was using just a flathead screwdriver, they had a brake adjuster, which was the perfect size, the perfect shape to take the job and then just get it done faster. So the right tool makes a difference. Back to the electric vehicle testing, what does it mean to have the right tool? 3 things. Number 1, the right tool increases engineering performance through software. That means that the software enables the design engineer, the test engineer, the operators, the technician, everybody involved to work better and have a better workflow. Number 2, it increases the test performance through the right hardware that is integrated. That means that not only the people are working well together, the equipment is working well together. You're not losing data, you're not wasting unnecessary energy, you are getting the results that you need when you need them at the point that you need them. And then third, it increases the product performance through connected data. This means that you're not only testing for passing or failing the battery, for example, you're testing it for performance to make sure that what gets to the car is the best performing one, not only the one that passed certain criteria. So increasing performance in these dimensions, it's going to increase the speed at which engineers are figuring this out, and it's going to drive adoption. And adoption will get us closer to sustainability and eventually to zero emissions. Because after all, we want that feeling of certainty. We want both the zero emissions and the feeling that we're going to make it. We want to know that we're safe and that we have a predictability in our trip. So sometimes I do miss my first car, my Beetle. It was a little unpredictable, but it was exciting as well. However, now when I'm ready to head on a road trip, I want it to go as planned. And when it does, it will be because of the long chain of diligent tests that started way before I packed.